50 nanometer, and their antibacterial efficacy study on bacteria isolated from UTI infection. At first, I want to tell you what is nanoparticles. Nanoparticles are particles ranging in size from 1 to 100 nanometer in range. We can synthesize it from normal chemical sources or from biological sources. Here I have synthesized this from biological sources, from acacia and TKP, and because I have applied it on biological cell lines means biological UTI infected patient. So I have taken it from normal natural three types. Size ranges from 13.6 nanometer to 42 nanometer, and from they are generally spherical in size. And spherical in size, and they have very different shapes. We need it to compare their depending on their size. Smaller size particles have greater invading property than larger size nanoparticles. So we are taking 13.6 nanometer as generally in more cases than 42 nanometers. And next slide, please. Next slide, please. Yes, yes. No, no, no. Previous one. Slide number 3. Yes. Here we activity of 3 silver nanoparticles on 4 strains, 2 from equally isolated from equally and 2 from earlier strains. Here is earlier strain. If from U2056 and U2039, these cells, these strains are generally we isolated from UTI infected patient. Equally, we know is a gram-negative bacteria, and Staph aureus we know is a gram-positive bacteria. Gram-negative bacteria have later, silver nanoparticles can infect gram-negative bacteria more prominently than gram-positive bacteria. The peptidoglycan layer. Rigid and more longer and thicker peptidoglycan layer for years is not so easily can be killed by our silver nanoparticle, but equally can be easily killed by the equally can be easily killed by the silver nanoparticles I have prepared. Here we can see that 13.6 nanometer have more effective means with lower concentration. It can give more bacteria than any other comparing to any other drugs. Here we take 3 concentration and 3 types of silver nanoparticles and measure their at 3 different concentration. And these concentrations are lesser in case of equally and more in case of Staph aureus. So we can tell that equally silver nanoparticles have more bactericidal activity. Staph aureus. Then next slide, please. Anamika, please. MIC values of different silver nanoparticles. MIC value means minimum inhibitory of different silver nanoparticles. MIC means minimum inhibitory concentration. Means the concentration required to get 50% of the bacteria can be killed 50% or 100%. Okay. But is 99%, we can kill 1 or 2 bacteria left. Sometimes we can kill 100%. It depends on the concentration, that how much concentration we have taken and how much bacteria we have killed. Here also we have taken 4 strains, 2 from E. coli and 2 from Staph aureus. So from E. coli, uh, but uh, silver C red red killing 2 strain of E. coli also, we can see that there is difference in the value of MIC at uh, Staph aureus also. If in the same concentration, we can get different values of MIC for the 2 strain. Okay, and we see A and that more. Yes. Yes, yes. For you can keep more efficiently by the silver nanoparticles, and then 2007 this strain. Yes, this strain. So I'm asking more in case for for years. So we can tell that we not only by having the concentration of silver and activity, but also to yes, yes, tell and zone of inhibition study. Zone of inhibition study by well human method. In this method, we have cutting wells and loading the samples, comparing with antibiotics, and we have zone of inhibition we can study by well diffusion method. Well diffusion method we can do by cutting wells. I have done some little bit. This inhibition study, we can see that it is more in case of the E. coli strain than is staph strain. Yeah, as staph aureus is a gram-positive bacteria and E. coli are gram-negative bacteria, so killing efficiency effect is more in case of gram-negative bacteria than positive bacteria. So zone of inhibition is more in comparison of among compare 3 silver nanoparticles, and it is more in case of 13.6 nanometer particles and then 42 nanometer particles. So and tell that zone of inhibition is more effective in case of smaller size of silver. Now you can proceed in the, you can go ahead and can
slide.
show the next. Next. Division is more effective in case of U256 than U2039 strain. Now, Monamika, can you please go ahead to the facts result? Yes. Epichem images, no, not the facts, epichem images, please. Epichem, yes, this epichem images. No, this is zone of inhibition study. This is already done. Epichem images, yes. Thank you, Anamika. I get the slide. So epichem images indicates the antibacterial activity we can see properly in case of untreated E. coli and in case of two types of E. coli, U256 and U2309 strain. These from this study we can see, in epichem images we can see that bacteria we can kill by silver nanoparticles. Cells are generally disrupted and cell walls are broken and cell gets shrinkage. So we can tell that with the treatment with silver nanoparticles we can kill cells. Here we have done only one type of cell, that we have taken only E. coli strain. We have not taken Staph aureus strain because this is very difficult to treat Staph aureus in our lab. So we have taken E. coli strain, so we can kill them easily. And we can tell that the silver activity that they have killed by the bacteria get killed by our silver nanoparticles. Now, the next slide, please. The facts result. Facts result. These are the facts result. From the facts result, we can see that the cell disruption, membrane disruption study and percentage of cell live and dead cell. The percentage of dead cell is more in case of E. coli than Staph aureus, and the membrane integrity is low in case of membrane integrity is low in case of gram-positive bacteria. Negative bacteria. More bacteria get so disrupted in more in case of gram negative bacteria than in case of gram positive bacteria. So we can tell that gram negative bacteria get more killed by than in comparison to gram positive bacteria. So from the zone of inhibition study, from MIC value and from bactericidal activity value, and again with the FSM images and from facts analysis, we can conclude that the silver nanoparticles I have prepared 13.6 nanometer, 22 nanometer and 42 nanometer have great bactericidal activity, and it can use as an antibacterial agent in comparison with the drugs where we get resistant bacteria. We can use it, and we can use it at ointment in future as silver nano ointment. So and now at last I want to complete my presentation, and want to thanks to all of you for listening it carefully. So any thanks to all of you. Okay. So any question you